So when we're considering an application, how do we decide that a system of linear equations is the right tool for the job? More generally, how do we decide that some sort of system of equations is going to be the right tool for the job? That second question is a little bit easier to answer. We will need to use a system whenever we have more than one unknown. Now that's a kind of a strange thing to say, because all the time in math classes, we have you solve things with more than one unknown, where you just represent everything in terms of one variable. But I'm going to tell you a secret. Frequently, we're secretly using substitution right in the process of setting up our model. So instead of giving our two unknowns two names x and y, and saying that y is x minus 3, we might just give our unknowns the names x and x minus 3. But anytime we have more than one unknown, we can model the situation using a system. So I'm going to show you kind of a toy problem that we model using a system. And we're not going to really think about the problem itself. We're going to think about how we know it calls for a system of equations. This problem tells us about Jim and his brother Dave. It tells us Jim is twice as old as his brother. 6 years ago, Jim was 4 times as old as Dave. How old is Jim now? Now, why do I call this a toy problem? Because seriously, why would you ever be asking this question if you weren't in math class? There are other problems that take on a similar form that you might ask in real life, but this is clearly a made-up problem for studying in math class. What makes me think that this calls for a system of equations? After all, we're only being asked for one piece of information. How old is Jim? But Jim's age, all of the information we have about Jim's age relates it to this other piece of information, Dave's age, right, which we also don't know. So it's pretty clear that we're going to have to also figure out Dave's age, or get close in the process of figuring out Jim's age. So these two unknowns, the fact that I have two unknowns, really suggests that a system is going to be in order. I hope I have enough information. I hope I have enough rules to build a system. What rules do I have? Well, I have this rule relating their ages now. And I also have this rule relating their ages 6 years ago. And I think that's it, right? And of course I have my background knowledge, which tells me that, for example, people age at the same rate. What have I just done? I've identified my unknowns, Jim's age and Dave's age, and I've identified the rules that relate them. There's one about their ages now, and there's one about their ages then. I think I understand this problem. I think that I'm ready to model it. I'm going to put the model in purple. My unknowns I'm going to give names to. I'm going to call Jim's age J and Dave's age D. I like to use lowercase letters for variables. It's kind of customary, unless you have a compelling reason not to use lowercase letters for the names of variables. Okay, so the rule about their ages now says Jim is twice as old as Dave. So that means Jim's age is twice Dave's age. All right, let's make sure I didn't get that backwards. Who's older? Jim is older. All right. J will be a larger number than D, provided they're both, positive numbers. All right. 6 years ago, Jim was 4 times as old as Dave. Right, so if Jim's age now is J, how old was Jim 6 years ago? He would have been J minus 6 years old. Jim's age then was 4 times, was it 4 times D? No, people age at the same rate. It was 4 times Dave's age then. Dave's age 6 years ago was D minus 6. All right. So how do I know if this calls for a system of linear equations? Well, here's my system of equations. Are they linear? In this case, they are linear. If they were not linear, we could not solve them using the techniques that we have. What should we do then? Well, we should make sure that we've modeled correctly. And if we're sure that we've modeled correctly, then we just are not currently equipped to solve this problem. If it's on a math test, we should complain. If it's a situation that we encounter in real life, we should learn more math and come back to it. All right, but in this case, these are linear. I'm going to have you guys pause the video and try solving this system. All right, we're now on to step 3, solve whatever we need to solve in the model. Pause the video and try this now. Okay, I think that this system is really nicely set up to use substitution. This first equation is in the form J equals something with a D in it. So I'm just going to substitute, instead of J, I'm going to write 2D minus 6 equals 4 times D minus 6. All right, now I have an equation in one variable. Simplifying the left-hand side, I notice that these parentheses aren't necessary, right? Multiplication comes first in order of operations anyway. On the right-hand side, I'll distribute. So I get 2D minus 6 equals 4D minus 24. All right, now I need to get all the terms with D on one side, all the terms without D on the other side. I'm going to choose to get my terms with D on this side because I like positive numbers. So I'll subtract 2D from both sides, add 24 to both sides. 2D minus 2D cancels out. Negative 6 plus 24, that's positive 18. 4D minus 2D, that's 2D. Negative 24 plus 24 cancels out. I get 18 equals 2D. Now divide both sides by 2. I get 9 equals D. Okay, am I done? No. I still need to find J. And I'm going to use this first equation to find J. J is 2 times 9 is 18. All right. Now it's time to answer the question. How old is Jim now? Well, Jim's age, that was J. J is 18. So my answer is Jim is 18 years old. Last step. Does this make sense? Well, the first thing that makes sense to me is that Jim is older than Dave. Can a person be 18 years old? Yeah, sure. What numbers wouldn't make sense here? Well, if I'd gotten negative 4, I'd know something was wrong. A person can't be negative 4 years old. If I'd gotten something like 116, I would have been pretty surprised also because, you know, most people aren't 116 years old. And mostly when people are 116, you've kind of stopped comparing them to their little brother. So, we've answered the question. Our answer makes sense. How did we know that we needed a system? We had 2 unknown things, and all of our information was about how they were related to one another. Even though the question only asked for one of them, we knew that there were 2 unknowns, and that cued us to set up a system.